Good morning. We're going to talk about acoustics specifically, but bearing in mind that there are a whole bunch of different components that go into making us successful, making us comfortable is a big part of that. I'm a scientist, so I love that things can be measured. And I love working with things that can be measured because then we know how we're doing with regards to success or failure. When it comes to each one of these elements, there are things that you can actually measure and therefore predict performance with. So all of them are equally important, though, with regard to how the occupant experiences the space and therefore how the outcomes really are. In this case, I'll be speaking about an office building as a case study for this approach of using science and using a systematic approach to solving problems that are presented by designs. As I said before, each one of these components is critically important towards creating this overall sense of comfort for a person in the space. If you think about yourself, you've got so many resources in the course of a day when it comes to your person as a being. You'll spend time towards distraction and healing if you're wounded. You'll spend time toward distraction of noise in loud environments. You'll spend time to distraction of, and resources to distraction of having an infection or having a head cold, or all these little things. Each one of these add up to the course of your day and where your resources are going to go and what you're going to do. So if you can control the elements around a person that can influence their need to dedicate resources towards being comfortable and reduce that expenditure, then you're leaving them with the sort of resources that dedicate towards other purposes. Ideally, the outcome of their day and the reason that they are in a given space. Although we're not going to spend a lot of time talking about things like daylighting and views, here are some startling numbers for people that run businesses with regards to daylighting and views. How much impact individual elements can have on the mission of that space, be it an office space. Look at communications and understanding information orally, 6 to 12% faster in the course of a conversation in the right environment. Hospital stays 8.5% shorter. Again, resources dedicated towards healing as opposed to distraction of noises clicking on and off in the room and things like that. Daylighting for students, not only having better scores, but actually learning to think faster. How do you teach someone to meet the challenges of tomorrow when you have no idea what they're going to be? Teaching them to think. And teaching them to think quickly appears to be very, very critical. More productive workers, 18% against the bottom line. Retail has jumped all over daylight. They know, put stuff out in daylight, have good daylighting in a space, and the sales skyrocket. Again, all these things are being measured. We're talking about people in general in office spaces, ranking them, we see lighting being a 23% possible increase in productivity. Ventilation and fresh air, 11. Control, 3. It's interesting because we're spending a lot of time recently talking about control and the need for control, but when measured, that sense of control only had a 3% movement on the productivity of the person in the space. Again, I love measurables because at least it's something we can fall back on and say, okay, how can we move that? Each one of those things we're attempting to improve upon. For today, though, we're just going to focus on acoustics because of our limited time. We're going to talk about how to create an office space where people feel comfortable talking normally without intruding upon others. Usually when we talk about speech privacy in an office space, it's not that what we're saying is so critically important, no one else can hear it. We don't want to disturb other people because we know what impact that has on us. And so we start to self-modulate our behavior based upon our perception of the environment. If we think we're being loud, we start dialing it way down. If we can't hear someone talking, we start dialing it way up. It's controlling that level properly and controlling it with materials. We have a design given to us. We have a variety of designs given to us for a space from a set of designers. We're going after all kinds of aspects here. We might be going for sustainability programs. We might be going for light. We might be going for air. We might be going for all these different elements. And in the end, once we have a series of designs, we have to start painting those designs with materials to see if we can actually achieve those outcomes. And the great thing is, at least with the materials, we have measurable quantities, physical properties that we know influence these outcomes. And all we have to do then is properly blend those to meet the perceived or anticipated goal of that space. When you hit it right, you get all kinds of amazing feedback from the people in those spaces. Acoustics, the study of acoustics goes back very far. The comments on acoustics go back even further. Florence Nightingale in the Crimea War talked about the sound of the battles and how damaging that was to the healing soldiers and how you had to take the people away from those noises in order for them to actually be able to heal. So this issue's been around for a very long time, and the recognition of its importance as just seems to go higher and higher every day. When we talk about the open place, we've heard a variety of great ideas this week and reasons for doing things differently. But the open place itself and the open space is definitely our current reality, and it's only going to grow for a whole bunch of reasons. The challenge is making those spaces work, obviously, as we all know. How do we get all of those goals, but in the end, give the individual the privacy, quiet, or environment that they need to succeed? Understanding what their goals are, mapping the teams, doing all the great things that we've heard about are critically important. And once we have that, how do then we therefore create a soundscape for that new team to exist? It's an environment, it's an acoustic environment that we're going to create for an individual team based upon the usage and anticipated usage of that space. Ultimately reconfigurable, but for now, we want to tune every surface around us to make us succeed. So we use proper sound absorbing material, the blocking that we heard. It's certainly not everything, but it is a critical component where you can introduce it to control the sound, the reverb time, the echo of a space. You know, I'm not gonna clap my hands now, but this room obviously has a bit of an echo with amplification going on. And we can spend all day talking about why that is and fixing it, but for now, that's the kind of thing that we don't wanna have going on inside a place where learning is going on. All these things together wind up to manage speech, intelligibility, and understanding. So here's the case study. It's an office building completed 4 years ago. It's roughly 250,000 square feet. It's LEED Platinum in 2 different categories. It has 800 people and 116 collaborative spaces. It is 100% open plan. There is not an office in this building. But look at that number, 116 collaborative spaces to 800 people. That means there's a lot of non-collaborative spaces too. You're open plan, but you've got both public and private space within that in the way the building is laid out. I'll be honest, we've been tracking it for 4 years and tracking the spaces. We have more collaborative spaces than we need. People don't use them with that great of a frequency in certain parts of the building, so we can start to reconfigure those areas because it is an open plan. The strategies for success are really, again, first establishing the priorities for the outcome of that team. Understanding the team and understanding what kind of environment is going to help them be successful. How you will promote collaboration in that space, but not create an acoustic issue where that collaboration becomes sort of a distraction. Again, having all the right materials to, in the end, manage speech intelligibility. And yes, it is. There is sound masking. Another big topic that you could spend days fully understanding for your space. But in the use of this space and the success of the space, sound masking is a critical component. I'll actually show you measurements about how that worked. So we're employing active and passive solutions in the space. Passive, materials that block, materials that absorb. Active, materials that actually will absorb sound and change their physical properties. There's wallboard today that absorbs about half the sound that hits it. Have you ever seen this? It has the permanently non-drying layer of polymer in the middle of it that vibrates. And so the wallboard doesn't look like it's moving, but every sound wave is actually making it move, and it eats about half the sound that hits it. There's all kinds of really cool active materials out there in what used to be passive surfaces. These are now very active and contributing surfaces in regards to making the place seem quiet. In the end, you've made a building so quiet, you have to introduce sound. It sounds ironic, but there's a reason for it. You'll see it as I go through the pictures of the building. There are essentially 3 different kinds of spaces in this building. There is the open plan office space, there are the collaborative spaces, and there are transition spaces. When I look at that picture, the space on the right, I can hear the echo of that, right? Can you hear it in your head? Oh my gosh, there's so much hard surface in there. How am I going to deal with the sound that's generated? And right around that corner, in that open space to the right, is a pantry with seating for like 30 people. So, the sound can really ratchet up, and that frankly is a problem place for the building with regards to sound levels and how loud it does get, and how it therefore bleeds into the rest of the building. But because we can measure it, we can also fix it. Inside a given workspaces, there's a whole lot of things going on to try to control that sound. What are we trying to do? We're trying to make sure that people in that space can hear people 2 or 3 cubes around them, and yet clearly hear everyone on the telephone. and have their voice not go much further than that, and only have them hear things within that radius. That's the radius of importance when it comes to information for them. Things from sounds from beyond that are typically intrusions and do not contribute to their success. So the primary solutions for the building are absorbing, blocking, making it so quiet that you actually have to add background noise. In the collaborative spaces, you need a lot of absorption. What we see is a lot of deconstructed ceiling plans in our world today, and you look in the ceiling there, you see your future, clouds and shapes. You have to put stuff in the air to eat the sound, or else it just bounces around. The great thing about clouds and shapes is they can absorb from all sides. So you don't need to fill the space. 30 to 60% of that space will maximize your absorption. You don't need to go beyond that. And now you can get really cool and you can change their elevations. You can put them on angles. You can create a really fluid looking ceiling with these. It's only limited by your creativity. And yet it gives you the deconstructed feeling that everyone's looking for. And the reality in this building was, this was actually constructed from 2 existing buildings and different floor heights. The open spaces in between them, we had to deconstruct that ceiling to make you not realize that it was changing almost 2 feet in height from one building to the other. And that little architectural trick allowed us to do that. However, it created a sound problem that was solved with these kinds of solutions again. So a lot of this going on in the open spaces. In the collaborative spaces or in the actual workspaces themselves, there's an awful lot of blocking, an awful lot of control about the human voice, because this is the majority of the spaces where there are people talking. In a collaborative space, there might be 1 or 2 people talking at the same time. In the open plan, there's 60 people within range of each other talking at the same time. So it actually generates a lot more background noise out there. You have to do an awful lot more control. In those large meeting spaces, here again, great daylighting and views of the outside because of the glazing. Inside, you're trying to maximize your absorptive surfaces with the ceilings and the walls the best you can to help absorb that sound and control it and eliminate the outdoor sound. Eliminate sound from coming outside that space into that space in order to keep it private. There is white noise in here because we have to generate something called a noise coefficient. The optimum noise coefficient for, and again, science, we can go back to this, I'll give you all these measurables going forward. But you want, for an open plan office, a noise coefficient roughly to 40. That's essentially equal to 46 to 48 decibels. For those of you that mention or measure open office plans, the average open office plan is around 68 decibels. That's 20 decibels higher. That's 4 times louder. Your average open office plan is 4 times louder than it's supposed to be. That's where it's supposed to be. And you can design to that, again, because there's a measurable equation that you can actually come up with for the space, and you can predict how it's going to actually perform. Comparing the actual results to the anticipated results. Not many people want to open their robe after they've gone on a diet, but we're going to show you how this actually works. There's the old space in blue and the new space in green. The new space has a really good reverb time, a really low echo. The funny thing about the old space is that peak of 1.2 seconds for a reverb time, that's auditorium-like reverb time, or a gymnasium or cafeteria-like reverb time, and that's right at the frequencies of human voice. The actual worst place we could have had that kind of response, and that's where we get it. We see the new building actually matches the anticipated reverb time, which is about 5.2, which is excellent for an office space. Creates very, very little echo. A lot of things were done. Again, to get there, we're showing you the actual noise levels with the masking on and off. With the masking off and no one in the building, it's 41 decibels. That's the background noise of the building. ANSI says the average school should be below 65 again. So this is 41. So turned off and no one in there, but turned on, it's actually very quiet. So we jack it up 5 decibels, which is a noticeable increase over the background noise levels. Here's the measurements. Admittedly, with it on, we see a certain area of the building where it is not good. We see an area, I can't point, right over here, with the masking on that it's way too high. What's going on? That's a corridor that leads down to that cafeteria in the open space I just showed you. What's the great thing about measuring? We can turn it off. And when we turn off the sound, we get better. So what we've done in that location is, in that location, we've dialed way back on the background sound. And we've been able to fix it. And all of a sudden, that goes back to green. If you don't measure it, you can't manage it. And with acoustics, you can measure all these things. You can measure the noise coefficient. You can measure the speech transmission index. You can measure the reverb times. So you don't have to guess. You can actually predict and measure how it's going to turn out. The speech transmission index, which is the most important thing, how well do you understand what is being said to you? We actually made it go about 6 feet. And after about 6 feet, it starts to get fuzzy. And after about 12 feet, you actually have to look at someone and watch their lips move to figure out what they're saying in an open office plan. and it still sounds quiet to your ear. When we map the building that way, and we did, on the left and the right are the exact same information, is right graphically a little bit easier to look at, we see that the red zone is where you can actually understand what is being said. So the person sitting at that workstation can actually be heard by one, maybe two people sitting at their workstations while they're talking at a normal speaking voice out in the open office. And we measured it all throughout the building. We found all kinds of cool effects going on, hallways that were contributing, columns that got in the way, but we mapped the whole thing out to make sure that we had the levels right. And in some places we had to raise the background noise level, and some places we had to lower the background noise level because of the groups that were there. Some groups make different noise than others. Some groups make more noise than others. So you actually can tune a system like this to make it work with each individual person in the room. So here's a measurement about on and off. This gets into standing desks. This is our new reality. What do you do when all of a sudden a person is standing up above all the levels of control around them and are now broadcasting to the entire room? Can you control it? Yes, you can. What we see is this is with the sound masking on. We have on the left, we have a person sitting, again, getting to one, maybe two people. Standing, still only getting to maybe one, maybe two people. Not bad. What we've done is we've jacked up the noise level, the background white noise in that space, so their voice hits that background noise level still in 6 feet after they stand up. So we've gone beyond the laws of physical control. We're now using sound control out in space. When we turn it off, that's what happens. They actually bleed out about 2-3 times as far. The standing desk can really, really project a person out there if you don't use some background sound to control it. Is it always a solution? No. In some cases, you will have made it too loud if you try to do that. In that case, you have to get into best practices, asking people not to take telephone calls when they're standing at their standing desks, things like that. You still have to work around. You can't always use a technology solution. Sometimes there's a behavioral solution you have to ask. And if a person doesn't like to do it and a person insists on standing up and walking around talking, you allow them to do that in other parts of the building, or you invite them to use other parts of the building while they're standing and talking. Wouldn't it be nice to walk down this corridor and look at the pond while you're doing that? Here's a great space over here where you can do that. So working with people sometimes is easier than working with the building. If you look at all these ASHRAE standards that we designed to, ASHRAE 90.1, ASHRAE 55, ASHRAE 62, it goes on, right? The funny thing is, if you actually look at, like, say, ASHRAE 55, you realize that our parents told us a lot of lies, and one of them is we're not that special. About 20% of us are special. You can design a building to perfect comfort standards, and if you get an 80% satisfied score back from your people, you've nailed it. I just saw an 88% satisfaction return. That is fantastic. Because ASHRAE tells us usually you're gonna have about 20% of the people are outliers. They will not fall inside your physical parameters that you've designed for them. They will not be happy. And so you have to create micro solutions for them. You can't change the entire space. I do not know a technology solution to get past all these things. Sometimes it's simply working with the people. And ASHRAE suggests that when you talk about those accuracy scores. In each individual space, there are a variety of solutions to go around, but they all come down to the 4 basic concepts of absorbing the sound that's generated in the room, controlling the sound that comes from outside the room, controlling the HVAC system noise. Really underestimated importance, usually done wrong. Listen to, if you're in a hotel that actually has ductwork in your room that goes outside your room, you hear everything. That's why you don't get much of that in your room. Ductwork is communicating through the entire building. There's a reason a ship's captain could say all engines full ahead in the middle of a battle and everybody heard him. There's 0 transmission loss in a pipe. Talking to a duct, everyone hears you. So if you're going to get quiet between spaces, you have 116 collaborative spaces in this building that you want those to be quiet and not have sound bleed out, you better seal the ductwork in between them or they're just talking to each other. So a lot of mechanical insulation, it's an overlooked aspect of our noise control in our buildings that we should be paying attention to. The mechanical system generates an awful lot of that background noise we're talking about. So really controlling that is very, very important. In the classrooms, you want people to project naturally for 8 hours and never have to raise their voice and have everyone hear them. We know all this. We see all the scores. We see all the test results and how important it is. There's an example of a large training room and how perfectly the human voice projects across there, but it's not one material. It's a whole bunch of different materials. The outcomes are important. As mentioned by previous speakers, having third parties figure this out for you is critical. You can't trust yourself when looking at yourself. We happen to use the University of Oregon's High Performance Environments Laboratory to do the surveying of the people and understand results of the building, and they published a paper on those results. They're pretty staggering. If acoustics is the worst thing about the open office plan, We just took 800 people from a traditional perimeter office plan that everyone said was perfect, the way it's supposed to be, and put them out into the open fields of a completely open plan, and every single acoustic category improved. That's not supposed to happen, is it? It is possible if you focus on this. Each one of these elements of daylighting or lighting of the space, the air quality of the space, the thermal comfort of the space, and the acoustics of the space can all be addressed beforehand. Design them into your program. Don't value engineer out the elements that make this happen. This isn't done by one thing. This is done by a lot of little things. It's getting them right and keeping them and managing them throughout the course of the lifetime of the building. Don't give them away. Make sure that you get all the things in there that you need to make it succeed. With 10 seconds left, these are the products, right? You don't need to remember them. The funny thing is, like on this project, believe me, the developer's going, come on, seriously. Give me 2 ceiling tiles, okay? I do not want an attic stock of 26 different ceiling materials. Sorry, that's what you get. And you have to maintain that. And when you change materials out because they're damaged, you have to put back like materials. So many times these projects get engineered down over time because of the maintenance of the buildings and what's going on. You have to stick with your BIM. You have to stick with your objects that you know and make sure that that's carried all the way through for the lifetime of the project, and you will succeed. In the end, again, this building has scored 2 platinums, big deal. The most important thing is more than 80% of the people in the building are happy. We're about to 84% now, which is extremely good. Again, a lot of materials. We're sorry about that, Mr. Developer, but this is what it takes. This building is 250,000 square footage, 100% glass. You know what the most expensive thing in this building is? The ceiling. The ceiling is the most expensive thing in the building. It's more expensive than the glass. But that's why you saw the acoustic scores that you saw, and that's why the building does succeed. I ran a minute over. I'm sorry about that. That was all we have. Thank you very much.